In the realm of document intelligence and knowledge mining, indexers play a pivotal role. An indexer is a tool or service that scans through documents, extracts relevant data, and organizes it in a way that makes it easily searchable. This process is crucial for businesses and organizations that deal with large volumes of data, as it allows for efficient retrieval and analysis of information. In this presentation, we will explore the intricacies of creating and running an indexer, delving into its components, setup, and optimization techniques. Indexers are essential for transforming unstructured data into structured, searchable information. They enable quick access to relevant documents, improving productivity and decision-making. For instance, in a legal firm, an indexer can help lawyers quickly find case files and precedents, saving valuable time. Similarly, in a healthcare setting, indexers can assist in retrieving patient records and medical research, enhancing patient care. The ability to efficiently search through vast amounts of data is a game changer in many industries, making indexers a critical component of modern data management. An indexer typically consists of several key components: the data source, the data extraction mechanism, the indexing engine, and the search interface. The data source can be any repository of documents, such as databases, file systems, or cloud storage. The data extraction mechanism is responsible for parsing the documents and extracting relevant information. The indexing engine then organizes this information into a searchable format. Finally, the search interface allows users to query the index and retrieve the desired documents. Each of these components plays a crucial role in the overall functionality of the indexer. The first step in creating an indexer is setting up the data source. This involves identifying where the documents are stored and ensuring that the indexer has access to them. For example, if the documents are stored in a database, you will need to configure the indexer to connect to the database and retrieve the documents. Similarly, if the documents are stored in a file system or cloud storage, you will need to provide the necessary access credentials and configure the indexer accordingly. Properly setting up the data source is crucial for the indexer to function correctly. Once the data source is set up, the next step is to configure the data extraction mechanism. This involves defining how the indexer will parse the documents and extract relevant information. For example, if the documents are in PDF format, you may need to use a PDF parser to extract text and metadata. Similarly, if the documents are in a structured format like XML or JSON, you can use an appropriate parser to extract the necessary information. The data extraction mechanism must be tailored to the specific format and structure of the documents to ensure accurate and efficient extraction. The indexing engine is the heart of the indexer, responsible for organizing the extracted data into a searchable format. Configuring the indexing engine involves defining the schema for the index, specifying the fields to be indexed, and setting up any necessary filters or analyzers. For example, you may want to index fields like title, author, and content, and use filters to remove stop words or perform stemming. The configuration of the indexing engine can significantly impact the performance and accuracy of the indexer, so it is important to carefully consider the requirements and optimize the settings accordingly. The search interface is the user-facing component of the indexer, allowing users to query the index and retrieve documents. Creating an effective search interface involves designing a user-friendly interface, implementing search functionality, and optimizing the search results. For example, you may want to provide a simple search box for users to enter queries and display the search results in a clear and organized manner. Additionally, you can implement advanced search features like faceted search, autocomplete, and relevance ranking to enhance the user experience. A well-designed search interface is crucial for making the indexer useful and accessible to users. Once the indexer is set up and configured, the next step is to run it. This involves scheduling the indexer to run at regular intervals, monitoring its performance, and handling any errors or issues that arise. For example, you may want to schedule the indexer to run daily or weekly, depending on the volume of new documents. Monitoring the performance of the indexer is important to ensure that it is running efficiently and effectively. Additionally, you should have a plan in place for handling errors, such as retrying failed operations or logging errors for further investigation. Optimizing the performance of the indexer is crucial for ensuring that it runs efficiently and provides accurate search results. This involves fine-tuning the configuration of the data extraction mechanism, indexing engine, and search interface. For example, you can optimize the data extraction mechanism by using more efficient parsers or reducing the amount of data extracted. Similarly, you can optimize the indexing engine by adjusting the schema, filters, and analyzers to improve indexing speed and accuracy. Additionally, you can optimize the search interface by implementing caching, load balancing, and other performance-enhancing techniques. Handling large volumes of data is a common challenge when creating and running an indexer. To address this challenge, you can implement techniques like data partitioning, distributed indexing, and parallel processing. Data partitioning involves dividing the data into smaller chunks and indexing them separately, which can improve indexing speed and reduce memory usage. Distributed indexing involves using multiple servers to index the data in parallel, which can significantly improve performance and scalability. Parallel processing involves running multiple indexing tasks simultaneously, which can further enhance performance. These techniques can help you efficiently handle large volumes of data and ensure that the indexer runs smoothly. Ensuring the security of the data being indexed is a critical consideration when creating and running an indexer. This involves implementing measures to protect the data from unauthorized access, tampering, and loss. For example, you can use encryption to protect the data during transmission and storage, and implement access controls to restrict who can access the data. Additionally, you can use auditing and logging to track access and changes to the data, and implement backup and recovery procedures to protect against data loss. Ensuring data security is essential for maintaining the integrity and confidentiality of the data being indexed. Monitoring and maintaining the indexer is crucial for ensuring its long-term performance and reliability. This involves regularly checking the performance of the indexer, identifying and addressing any issues, and making necessary updates and improvements. For example, you can use monitoring tools to track the performance of the indexer and identify any bottlenecks or errors. Additionally, you should regularly review and update the configuration of the indexer to ensure that it continues to meet the needs of the users. Regular maintenance and monitoring can help you ensure that the indexer remains efficient, accurate, and reliable over time. To illustrate the practical application of an indexer, let's consider a case study of a legal firm. The firm deals with thousands of case files, legal documents, and precedents. By implementing an indexer, the firm can quickly and efficiently search through these documents to find relevant information. For example, a lawyer can use the search interface to enter keywords related to a case and retrieve all relevant documents within seconds. This not only saves time, but also improves the accuracy and thoroughness of legal research. The indexer can also be configured to automatically update the index as new documents are added, ensuring that the search results are always up to date. In the healthcare industry, an indexer can be used to manage and search through patient records, medical research, and other important documents. For example, a doctor can use the search interface to quickly find a patient's medical history, lab results, and treatment plans. This can improve the efficiency and quality of patient care by providing doctors with quick access to relevant information. Additionally, researchers can use the indexer to search through medical research papers and clinical trial data, helping them to find relevant studies and data for their research. The indexer can also be configured to comply with healthcare regulations and ensure the security and confidentiality of patient data. The field of indexing is constantly evolving, with new technologies and techniques being developed to improve the efficiency and accuracy of indexers. Some of the future trends in indexing include the use of artificial intelligence and machine learning to improve data extraction and indexing, the development of more advanced search algorithms, and the use of cloud-based indexing services to improve scalability and performance. Additionally, there is a growing focus on ensuring the security and privacy of indexed data, with new techniques being developed to protect data from unauthorized access and tampering. Staying up to date with these trends can help you ensure that your indexer remains efficient and effective in the future. Creating and running an indexer is a complex but essential task for managing and searching through large volumes of data. By understanding the components of an indexer, setting up the data source, configuring the data extraction mechanism and indexing engine, creating a user-friendly search interface, and optimizing performance, you can create an efficient and effective indexer. Additionally, by implementing measures to ensure data security, handling large data volumes, and regularly monitoring and maintaining the indexer, you can ensure its long-term performance and reliability. With the right approach and techniques, an indexer can significantly improve the efficiency and accuracy of data management and retrieval.